In this problem, we will see why did the cow cross the road. In this problem, Farmer John has a lot of fields that might have a lot of roads, making it impossible for the cows to travel around without crossing many of them. The farm is arranged as an n by n grid of fields, where n is between 2 and 100. Certain pairs of adjacent fields are separated by roads, and a tall fence runs around the external perimeter of the entire grid. Cows can move freely from any field to any other adjacent field, although they prefer not to cross roads unless absolutely necessary. There are k cows where k is between 1 and 100, and k will always be less than n squared. Each cow will be located in a different field. A cow is said to be distant if, in order for one cow to visit the other, it is necessary to cross at least one road. The goal of this problem is to find out how many pairs of cows do we have that are considered distant. Our input format is one input file that contains n, k, r, and the next r lines describes the roads that exist between the pairs of adjacent fields, and the final k lines indicate the location of the k cows. The output is simply just an output file that displays the number of pairs of distant cows. In our program, our input file should be called countcross.in, and our output file should be called countcross.out. Time to approach this problem visually. Using the sample input from our problem, our file should look like so. The first line represents n, k, and r. N is the size of our grid, so in this case, n equals 3. So our grid is a 3 by 3 grid. Our second number, k, represents the number of cows we have. Our third number, r, will represent the number of roads that we have in our grid. The next r lines, which in this case is 3, will represent the pair of fields that have a row between them. The format here is row and then columns. So the first road is located between the coordinate 2, 2 and 2, 3. The next road is between 3, 3 and 3, 2. The last road is between 3, 3 and 2, 3. Our last k lines will represent the cow's coordinates. We have a cow at 3, 3. Another one at 2, 2. And lastly at 2, 3. So how do we determine if a cow is distant? Visually, we can look and see that there is one cow at the corner at the location 3, 3 that is separated from the other two cows by roads. Due to this means that the cow is distant from the other two cows. The cow at location 2, 2 is not considered to be distant from the cow at position 2, 3 due to how the cow can go around the road to reach the other cow. Again, these cows prefer not to use roads if possible. So we need to somehow figure out how do we determine using this information if a cow is considered to be distant or not. We are going to use a method called flood filling. Basically, starting from the beginning, we are going to mark the whole area that is not completely separated by any rows to be one number. So for example, the first field we are going to set here is noted to be as number 1. Then we mark the next field with the number 2, and so on. Since this grid is small, we technically only have 2 notable fields. If the problem were bigger with many more roads, we could have run into many more numbered fields. From here we can see in this problem, we note that we have 2 distant pairs, which matches our sample output of 2. For our programming problem, we have to have a fence around the n by n grid as well, so we will not technically make another layer of field around the grid. This will represent our fence. We will need to address this when we make the code. We also need to determine a way on how do we know if there's a row between 2 adjacent fields or not as well. We are going to be using a method called powers of 2's to be able to determine if there is a row between 2 different fields or not. That will be discussed in the code. Then we will also need a method to determine how we are going to fill each adjacent field with an appropriate room number. For example, starting at one field, going up will be -1 on the row and 0 on the column. Going right will be 0 on the row, but 1 on the column. Going down will be 1 on the row and 0 on the column. And going left will be 0 on the row and -1 on the column. So for some pseudocode, we will need to figure out a way how we can mark our whole field. So we're probably going to need a for loop. A double nested for loop, in fact, that checks throughout the whole field that if the area is marked or not, we will mark it ourselves. We are going to use a DFS method to mark our room numbers. We're going to check the 4 neighboring fields of each individual field that we check to see if they are marked or not. If they are not, then we will call the function again using recursion to mark the field. Let's go over how we will represent our roads on our field grid. For any field on our grid, we will have 4 sides that will be represented by a 4-digit binary number. 0000 means that we have no roads around the field. Starting from the top and going clockwise, 0001 means that we have a road to the north. 0, 0, 1, 0 means we have a road to the east. 0, 1, 0, 0 means we have a road to the south. And 1, 0, 0, 0 means that we have a road to the west. Each bit will represent a numerical value that we can add to each other. Starting from the rightmost bit will represent 1. The second from the right will represent 2. The second from the left will represent 4. And the bit on the left will represent 8. Using this information, we can use any combination of roads around the field to get a unique value. For example, we have 0, 1, 1, 0, which means that we have a road to the east and to the south, but no roads to the north or the west. Using the values that each bit represents, we get a field value of 4 plus 2, which will turn out to be 6. We will be using this method in our code to determine how our roads appear in our field grid. From here, you have a lot of the information that you may need to solve this problem. I encourage you to try to solve the solution yourself, but I will also provide you the code and how we approach this problem as well right after this. Time to do this code. I'm going to make a few variables and such that we will need for this problem. I am going to type define a pair of two integers and call it pi. This variable will be used to store the location of a specific cow. We will then make an array of pi called cows and make it of size 105. This will be my array containing all my cows on my grid. I'm going to make a few global integers, one called answer. I will need one for the size of the grid, the number of the cows, how many rows we have, and a couple of other ones for directional movement along rows and columns. I will then make an integer two-dimensional array called Mart of size 102 and 102. The reason for the extra 2 is to handle our fence. This grid will be our Floodfill grid. We will then make a two-dimensional integer array called field as well to keep track of how our field looks and keep track of our roads. Then I'm going to make an integer array of size 4 and call it dr to represent the direction in the rows. These values will be -1 for going up, 0 for going right, 1 for going down, and 0 for left. We make another int array of size 4 called dc to represent the direction in columns. The value will be 0 for going up, 1 for the right, 0 for down, and -1 for left. In our main function, we first need to open our input file as well as our output file so we can read and write to these files. According to our problem description, these files should be called countcross.in and countcross.out. Of course, to read files, we're going to need the library fstream. Our first inputs from these files will be our n for our grid, our k for our number of cows, and our r for the number of roads. After that, using a for loop with the variable r, we will then read the next r rows of input to determine where our roads are. We take the input as format row 1, column 1, row 2, column 2. If the row of the two fields are the same, we check if the neighboring field is either on the left or on the right when it comes to the road. We will mark our field grid to have +2 in the first field and +8 in the second field. Otherwise, we will mark our field to be +8 in the first field and +2 in the second field. If the rows are not the same, then we check if the neighboring field is either above or below when it comes to the road. We mark our first field to be +4 and our second field to be +1. Otherwise, we mark our first field to be +1 and our second field to be +4. Now, what do all these numbers mean? We are using a numbering system called powers of 2 to note where the road is located between the two fields. If I was looking at one field, and if a road was above to the north, then that means that our field will be marked with 1. If there is a road to the right, that means that our field will be marked with the number 2. Bottom would be 4, and left would be 8. When we add these values to the field slot, we get a number that represents where the roads are around this field. For example, if we had a road to the left and to the right of the field, then we have a unique value of 8 plus 4, meaning that the value of the field will be 12. This is just a handy way for us to determine, by looking at our field grid, where our roads are exactly located throughout our whole field. Next, we gotta make our fence around the whole grid. We make a for loop that loops 1 through n times. We mark each slot we find around the grid with the value of 1 to represent our fence. This way, the grid is marked, so when we use our Floodfill, we won't need to go outside of our initial n-sized grid. Now for the number of cows k, we read the last inputs of the file that represents the location of each of our cows. We are going to initialize a variable called room number and make it equal to 0. The reason for this is because since we haven't even started counting our rooms yet, we start at 0. Now we got to check our whole grid. We make a set of nested loops to go through each spot in our grid. We check if the spot is marked or not. If it's not, then we will use our function that we will make called Floodfill to mark our room with the room number we want to use. Now let's make this function. Our function will take in 3 parameters: row, column, and the room number. We are going to mark our current row and column with our current room number. We then use a for loop to check the 4 cardinals of this field, or the 4 neighboring fields of this field. Using our dr and dc array that we created for the directionals of the rows and columns, we will go through each slot and check if the neighboring field is visited or not, or if there's a val in between. To check if the field has a wall between, we will use a bitwise shift to the left. If it is not marked or does not have a wall in between, we will use recursion to call the floodfill function again. This will conclude our floodfill function. Lastly, for each cow, we will now check how many cows are in different rooms or separated completely by roads. So the first for loop is for checking for each cow, and the second for loop is for checking how many cows are in a different room. If the room number of the cow is not the same as the next cow we are checking, then we will increase the answer variable by 1. Then lastly, we write to our output file our answer, and this should conclude our program. So using the sample input from our problem description in a file called countcross.in, let's test our program to see if it outputs to our countcross.out the sample output of 2. And as you can see, we got the sample output of 2.